people are trying to make the cool roof by changing the color or the material that they paint, the roofs. That changes the reflectivity of the sunlight. The other idea is, to have basically green, roof on top, to have the plants. And basically, those are the two things, that use the roof. Maybe we can give a break at this time. How much longer do you have? Maybe I have to run, and get my charger or something.
I'm in the half of the presentation.
Okay.
50%, so even less than 50%. But I have to increase the speed a little bit.
So let's have another 10 minutes or so. See, probably the calculation we can skip, because...
Right, I'm going to pass through and go through ideas, basically.
The other option is I could download whatever app it is you're using whether I've got full charge in here.
Can you?
Yeah.
Actually, what I do, if you log into my, basically, Dropbox, that's what you, Okay, you can continue and then we'll work on this thing. Sorry.
So glasses are the same way, because if you look at glasses, great source of energy passing through glasses, winter or summertime, right? Sunlight is coming, and not only because of the temperature difference between inside and outside, but also because of the sunlight, radiation. So in this winter time, as much as it is pleasant to have a lot of sunlight coming inside, right? Because you can increase the temperature of the room, breathe. But in the summertime, it's going to be troubling because the amount of the energy you have, your HVAC has to work for it. Now the question is, so what do I do with that? That's why in the northern hemisphere, it's a good idea, it's recommended to build the houses as they face south. Right? Because what happened is the air tilted during the winter time, right? So what happened is then in the summertime, you are going to have minimum exposure from the sunlight coming inside the room, and in the winter time you have the maximum sunlight coming from the sun. So it's perfect. If you live in the southern hemisphere, it's the other way around. You better have the house facing north, basically. So it's the same for glass. There are charts that you can calculate in, reducing loads. Now, there are other ways. You cannot always build a house facing south if you're living in the northern hemisphere. There are many, many different reasons for that. So how do I do that if I cannot build a house facing south? You can still do a lot of different things. You can have solar control films on the glasses. If you look at all of the commercial buildings, that's one of the reasons you see the glasses are all dark, right? Because they want to control the amount of the sunlight coming. You can have screens, and these screens or shading can be outside or inside, depending on how they are. And you can adjust the level, right, of the sun that you can get. And typically, you have different type of a configuration. You have a regular window. On a regular window, 100% of the energy that is coming, about 72% of it is passed, and it comes to the room. If you basically add a reflection glass inside, that reduces it to 30%. But the problem with reflection glass is in winter time, you like that energy to come in. But now in winter time, you block that too. So that's why using a configuration like double glaze with shutters, and if you put the shutters inside or outside, it has a huge difference. If you have the shutters inside, it's about 50% reduction. If you put the shutter outside, you reduce it by 85%, right? But outside shutters are more expensive, difficult to maintain, right? If you have a 30-story building, who's going to take care of the outside shutters? There's a maintenance charge. That's why a lot of shutters are inside, basically. So windows are very important. As much as we like them to have more because it gives us view, but maintaining them, accounting for the energy, it's a cost. Somebody has to pay for that cost. Pass some of these things. And as windows get old, infiltration becomes a big problem. You know, the windows that you have at home that are sliding windows, none of them are closed completely, right? You're fortunate that you're living in an area that you really don't care. But if you were living in Minnesota, northern part of the country, every year you have to pay some amount of money to put, you know, heat strap around it, make sure everything is sealed, make sure everything is lubricated, the windows are closed, you know. Used to live in Michigan, I used to do all kinds of things like that every year, basically. And, but here we don't care. So I talked about that. Now,
So we have another one here.
oh, yeah, use the
Just
juice.
1%.
1%.
Is it? Okay, good.
So what happened here is, if I have a big building, I think this is the last slide for this chapter.
Okay.
If I have a big building, like an office building, or a commercial building, or a commercial mall actually, now the technology exists. You can have thermometers at different locations, all wireless. Give you command to a control room somewhere. You have the temperature reading of every location, and depending on the temperature reading you have at that location, you have dots to open and close. Before, it used to be, oh, okay, I have one thermostat somewhere, either, you know, the temperature of that place, based on the temperature of that place, the whole building is going to get cool or warm. Now it's not the case anymore. With using of the computer technology, you can monitor temperature at different locations. Different rooms actually require different type of a temperature. And if you look at the standards that are in the market, what is in for classroom, what is for office building, what is for bathroom, they are all kind of different requirements for temperature. And every degree counts basically, right? Yeah. So the purpose of showing some of this calculation is not for you to learn how to calculate inflation and interest rate and so on. The purpose is to show you these capabilities existing. We can calculate all of these energy losses. We can calculate it for every BTU per hour. And everything is calculable, basically. Right? Anything in the energy system, you should be able to calculate. So we talk about different kind of system. Let's talk about a little bit on electrical system. And when you do that on the auditing for electrical system, what do you have to take into account? Right? So now for building, you know, when you are auditing a building, you have to make sure that the window sizes, glasses, walls, material, installation, orientation of the building, square foot of the building, operation hour, all kind of things are factors, right? So for electrical system, first of all, electrical consumption accounts for 50 to 70% of utility bills. It's a huge amount, and it's increasing more and more, right? Because electricity is easy to transfer, and it's very high efficient, and everybody likes it basically. And when you're looking at the equipment, when it comes to that they are using electricity, you've got to divide them to the systems that are basically used for lighting. You audit them differently. The systems that are mainly for electrical motor and driving a load, we audit them differently. And there are some systems that are placed for basically compensation of load factor and demand. And we're going to talk about those also a little bit, not too detailed. So lighting energy, as in the example I gave you, is a great energy consumption, either in residential or in industrial place as well. So when you're dealing with lighting, you cannot just go and say, okay, I'm going to change all of my lighting to lower wattage. If I have like 100 watt lighting, I'm going to reduce them to 75 watt, and I'm going to reduce 25%, my energy consumption. So every location, depending on the usage of that location, a certain amount of the light is needed. And you have to provide that certain amount of the light. The important thing is just to make sure that you are not over-providing it, basically. So when it comes to lighting, you need to make sure that you know the office or the space that you're dealing with, what kind of a space it is, so you can find the specification for it, the fixture characteristic, and you have to evaluate the